All right. Hey there, physical science students. This is Mr. Barry at SCORE Academy. I'm here today to explain Custom 4, motion and the forces affecting it. I just want to make sure that all the directions are clear. And if you're not sure how to answer some of these, that you kind of see how it works, how the simulations work, all that good stuff. So, going to jump into it. You are at a spot where you've started the physics portion of physical science. If you're looking at this one, you can see the standards that are covered here. And if you're ever curious, you can check that out. And a reminder then, everywhere that there's orange text, that's where you'll be answering some questions. So keep an eye for that. Hopefully the orange text makes it pretty obvious and it helps us as we're grading also see where it is that you've, put your responses. So part one here talks about graphs of motion. There's a little link right here that will bring you to kind of a key that will show you, some details about these. So a couple things real quick as you look at this. First, notice that it's distance in time in this column here, kind of this middle column, and it's velocity in time in the right column. Always make sure that you are, noting what is on the axes as you look at this stuff, okay? And then just consider what you're looking at, and it tells you with a descriptor over here what's happening, right? So this black line on the right ones is meant to be the spot where it's zero. So you see here, constant positive velocity, it's moving forward with a constant speed, or here it's moving backwards with a constant speed, and that's why it's down below the zero. All right, so note the shapes of the graphs and just kind of what else is going on, and it tells you what's happening over here on the left. It's really important as you look at these graphs and consider what's happening in them. So I want you to tell me kind of which one is, a positive velocity, which one's a stationary object, which means it's not moving, which one is not accelerating, okay? So that could be also not moving or going at a constant speed. And then which one represents an object slowing down. So it would be going from a high velocity down to a lower velocity. I also want you to note here, there may be multiple correct answers for these. Some of them, there are definitely multiple correct answers. So consider that too, please. Moving to part two, we're gonna use this simulation from PhET as we do all this. And I know the directions are kind of up here, and then it doesn't ask you to do stuff until down here. So please just make sure you're seeing that whole part of part two here. So that link takes you right here to this simulation. I'm gonna start on the net force, and you'll notice there's two parts here, right? One uses net force, and the other uses the motion, okay? So net force is the first one, and then motion, you can change it right down here at the bottom. You can go back to the home screen if you want also, but you can just change it right there at the bottom by clicking on motion. Okay. For net force, you can choose different size people to do a tug of war. So just make sure you're, sorry about that. You're, following the directions and seeing what you need to do there. It shows you all these items here, but make sure it tells you in the directions too to check all these boxes up here so that you know everything that's going on. Okay. It makes it more obvious to see those things. And then the motion part, you can push with this guy as you're pushing here, or you could change the force down at the bottom. So either way, if I use my little robot here to push this, or if I change my force down here, I can switch that up. I can always reset it if I need to up here in the top right. And then I can put some extra stuff on there if I want to add some mass and make it so I'm pushing more there, okay? Now it's harder for him to push because it's got more mass to it. So that's what we're doing here for the motion part. So there's net force, there's motion, and you change those down at the bottom of your screen. The last part here talks about Newton's laws of motion, right? If you need the reminder, you can check the link right here, and it'll take you just to a quick little summary of what each one is, right? So Newton has his 3 laws of motion, and they're all available right there. An object in motion stays in motion, object at rest stays at rest. And that happens basically until a force is applied to it, right? So whatever's sitting on your desk right now stays there until you push it. Second law is that equation that we've used so much in this class already, if you've gotten to this point. So force is mass times acceleration. And third law says equal and opposite actions, right? So if you push against something, they push back, all that good stuff. I want you to consider those and then think about something that you do in your life that is relevant to your personal life. All right. So a sport, an activity, a playground game, anything that really requires some sort of force and movement. I want you to tell me what it is here. And then I want you to consider the forces that are happening. So first, what force are you applying? And then what is happening as a result of that? All right. That may not be a force. Maybe you push something and it moves. That would be what happens as a result. After you've kind of outlined what the force happening there is, I want you to consider which of Newton's laws is actually present in that force and that action. And then tell me the number of it, first, second, or third law. Tell me what that law is, okay? And you can really look at what's on that sheet there to help you out with that one. And then briefly down here at the bottom, so these are all short responses, right? You're just kind of giving me the quick response there. And the last one, you're going to explain how Newton's law is present. So kind of give a description as to, oh, this is the equal and opposite forces, and so it's Newton's third law. So hopefully that helps clarify what you're answering here as you do all these different portions. Always try to respond where the orange is, please, and good luck.